right? Let's say the question is asking you something like this: what's the last digit of 2 power 16, right? So if the question was asking you to find the last 2 power 16, let's try to do something like this: 2 power 3, 2 power 3, because I know 2 power 3 is 8, or rather 2 power 4 is 16, right? And 2 power 5 is 32, and 2 power 6 is 64, right? So I can do 2 power 16 as 2 power 6 into 2 power 6 into 2 power 4, right? 6 plus 6 is 12 plus 4 16, so that's same, basically same. I can split. I know 2 power 6 is 64, and 2 power 6 is 64, and 2 power 4 is 16. So that's fundamentally looking at the last digits: 4 into 4 into 6, 4 4 is 16 into 6 is 96. So the unit digit is 6, right? Yes, it's taking time. There are, like, what if the question is asking you what's the last digit of, right? Sorry, this is going to take really long time for you to actually calculate it anyway. One thing which we can understand from the previous explanation is that 243 power 283 is basically same as 3 power 283, right? That's because to find the last digit per se, so it's basically the same. 243, I'm just focusing on the last digit, so it's basically 3 is multiplied 283 times to find the last digit. So to do the problems related to powers, let's try to understand a concept called cyclicity, right? There's a behavior you see in this, and we use that to solve the problems. Don't be scared looking at this table. I'll explain so that will actually make it easy to understand. Uh, so what we see here, 1, 2, 3, these are the unit digit just taken 1 to 9, and these are basically raising the powers. Like, this is fundamentally 1 power 1 is this, 1 power 2 is this, 1 power 3 is this. So we have written only the units digit in all the places, right? So let's just go about 2, right? So this one is 2 power 1 is 2, which is what the units digit is saying. This 2 power 2 is 4, which is what we have written. This one is 2 power 3, 2 power 3 is 8. This one is 2 power 4 is 16, so we have picked the last digit, so we have written 6. 2 power 5 is 32, so the last digit is 2, we have written 2. Right, then 2 power 4 is 64, 128, 256, 512, so the last digit is 2, 6. See, that's what you have written, right? The same case for every. So this is basically 4 power 1, 4 power 2, 4 power 3, and the last digits. So let's focus on the 2 again. See, the first 2 power 1, the unit digit is 2. Then I'm getting 4, then 8, then 6, and then again I'm seeing 2, right? And then again I'm seeing 4. Then again I'm seeing 8. Again I'm seeing 6. And again I'm seeing 2. So 2 power 10 would be 4. 2 power 11, 6, 8, 6, and so on, right? It keeps going on. It repeats for every digit. Let's look at 7 first. Say 7 power 1, 7. 9, 3, 1. Again 7. Again 9. Again 3. Again 1. Right? You see, for 9, 1, 9, 1, 9, 1. Yes, it's repeating only every 2 times, right? Here I'm seeing the repetition happening every 4 times. 7931, 7931, 7931. But everything you see is max 4. It actually happens sometimes for less than that, like what you see for 9, right? It's repeating every 2 times. But it is also fundamentally following the logic that it is repeating every 4 times, right? 9191, 9191, and so on. And then you have digits like 5, 6, 1, which fundamentally gives you always the same 1, 1, 1, 5, 5, 5 power 1, 5 power 2. All times you get the same units digit, right? So this is basically called the cyclicity concept. That's fundamentally the repetition, the pattern we are seeing, right? It's repeating every 4 times, right? Like after the 4 parts, I'm seeing the repetition starting. So how do we use that? Let's get to that with an example. Right, if you ever see a question asking you, right, 47 power 23, this is fundamentally asking you to find 7 power 23, right? So first what we need to do is, because you have seen the repetition happening every, like powers, like every fourth power, right? Like 2 power 1. So that's, let me write this here, right? So 2 power 1 is same as 2 power 5 is same as 2 power 9. Similarly, 2 power 2 is same as 2 power 6 is same as 2 power 10, right? With respect to the last digit, 2 power 3 is same as 2 power 7 is same as 2 power 11, and so on and so on, right? 2 power 4, 2 power 8, and 2 power 12. You see, 1 plus 4, 5, 5 plus 4, 9, 2 plus 6, 4, sorry, 6, and 6 plus 4, 10, 3 plus 4, 7, 7 plus 4, 11. And you see, this is fundamentally adding 4 to the powers to get the same last digit, right? 2 power 1 is 2, 2 power 5 is 32, again 2, power 9 is 512, again 2. That's what we're seeing. So all I need to focus is on the powers, right? Divide with the 4. Whatever the remainder I'm getting would give me a clue about what should be the last digit, right? Let's say, again using the same logic, right? The steps to do follow is focus on the power first, right? So the power is, let's see, right? 23 divided by 4. What would be the remainder? The closest one multiple of 4 is 4 5 is 20, right? 4 6 are 24 is greater than 23, right? So the remainder is 3, right? Once you know the remainder is 3, so that means 7 power 23 is same as 7 power 3 in terms of the last digit, right? 7 cube is 343, so I know the last digit is 3. So the last digit of 47 power 23 is also 3, right? Let's say if the question was 47 power 29, okay, just for our understanding. So again, focus on the power 29 divided by 4. The remainder is 4 sevens are 28 is the closest multiple. So the remainder is 1. This is same as 7 power 1 in terms of last digit. So it's 7. So the answer is 7 for this. Right? That is how you will solve the questions for the last digit or unit digit, focusing on with respect to the powers. Right? So this one is something related to the powers. It's asking you to find the unit digit of 33 raised to 232 factorial. So 232 factorial means basically 1 into 2 into 3 into 4 into so on up to 232, right? So as I said, the first step is find the remainder when the power, right? 232 factorial is divided by 4. Because 232 factorial is basically 1 into 2 into 3 into 4 into everything. So when I divide by 4, the remainder will be automatically 0, right? So that means 33 power 232 factorial is same as 3 power 232 factorial is same as 3 power 4 and not 3 power 0, okay? Because the remainder is 0, don't take it as 3 power 0, because anything raised to, right, is 1, so we get the answer as 1, but that's not correct. What you need to do is, it's if the remainder is 4, I have to take 4. The remainders you get would be 0, 1 and 2 and 3 when a power is divided by 4, right? Any number, because it's 4, so it has to be either of these 4. So if it's 1, I'll take it as 1. If it's 2, I'll take it as 2. If it's 3, I'll take it as 3. But if it's 0, I should take it as 3 power 4, right? For any digits for that matter. So what is 3 power 4? 243. So that's the last digit you get for this whole expression. Find the remainder when 1, 2, 3, 4 power 233 is divided by 10. See, when any number, right, let's say 1, 2, 3, 4 is divided by 10, just simplifying it, not the whole power part, right? What will be the remainder? It's the last digit, basically 4. Because if a number is ending with 0, it is divisible by 10. If it is having something, the remainders will be automatically those extra numbers, right? So that's another way of asking you to find the last digit. When I ask you divided by 100, that's fundamentally asking remainder when divided by 100. It's fundamentally asking you to find the last 2 digits, right? Now the question is asking you to find 1, 2, 3 power 4 233, right? So that's fundamentally asking me to find the last digit of 4 power 233. So let's focus on 233 first. What will be the remainder when 233 is divided by 4? right? I'll get a remainder of 1. So that means this will boil down to 4 power 1. So that's 4. That's the answer for the remainder when this is divided by 10. That's basically 4.